All right, so section 4.2, expected values and standard deviation of random variables. Don't know how much we're going to talk about standard deviation, but we'll talk about at least the expected values. All right, so I think the hard part is mostly the making the probability density function, but that we talked about in 4.1. Because once you have that, it's pretty easy to find the expected value, because all you have to do to find the expected value is just multiply your variable with its probability. So that's just basically taking your table and multiplying your table together. So if you go back and look at 4.1, there's a problem that we did where we had a lottery, and there's a 1 in 10 chance that you win. And if oh wait, no, I'm sorry, I'm thinking of a different problem. Different problem is this one. You roll a die, and if you roll a 2, 3, 4, or 5, you win $1.50. If you roll a 1, you lose $1. If you roll a 6, you lose $6. And we made the table. Let me pick a color here. We made a table. X was the amount of money we win or lose. So remember, we either lost $1, lost $6, or we won $1.50. Okay. Now the probability of those happening, well, if we lost $1, it's because we rolled a 1 out of 6, and there's only a 1 out of 6 chance of rolling a 1. We lost $6 if we rolled a 6, which is a 1 in 6 chance of rolling a 6 on a die. We won $1.50 if we rolled a 2, 3, 4, or 5, which is a 4 out of 6 chance of rolling a 2, 3, 4 out of 5 or a 5. So that was our density function. Now to find the expected value is just multiplying the outcome variable, the amount of money, with its probability, and then adding all of them up. So you can see you multiply the -6 with the 1/6, and you add it with the -1 times the 1/6, and you add that with the 1.5 times the 4/6. And it gives you your expected value, which is -1/6. So again, that's talking about sort of the average that you expect to lose or win. Obviously, since it's negative here, we're losing. But that's all it is. So once you have the density function made, it's just a matter of multiplying them together and adding them all up. So VideoMax has a promotion featuring 3 premium labeled DVDs and 5 discount specials. Each premium labeled DVD, which by the way, hold on, let's go back track. 3 premium labels and 5 discounts. So that's a total of 8 DVDs. Coming back to that in a second. Each premium labeled DVD sells for $24, and each discount special sells for $16. 2 DVDs are selected at random. So of the 8 that are there, you're going to pick 2 of them. Okay? Picking 2. There's 8 in front of you, you're picking 2 of them. Random variable X is defined as the total cost of the DVD selected. So basically, you're going to pick 2 of them, and how much money are you going to walk out of the store paying? Well, there's a couple different possibilities, right? So X, remember, is our variables. X represents the number of ways, it's number of outcomes or different outcomes that exist in the problem. So let's think about the different ways I could spend money. I'm going to pick 2 DVDs. Now, it's possible I pick 2 discount special DVDs. If I pick 2 discount special DVDs, then I'm spending $16 and $16, which means I'm spending $32. Okay, well, what are some other possibilities? Well, another possibility is I select 1 discount DVD and 1 premium DVD. Now, if I buy 1 discount DVD and 1 premium DVD, I'm spending $24 and $16, which is a total of $40. And the only other outcome is where I buy both premium DVDs. The 2 DVDs I buy are both premium. Running into some issues here. All right, 2 premium, which means $24 and $24, which is a total of $48. So when I walk in and buy 2 DVDs, I'm either going to spend $32, $40, or $48, just depending on which DVDs I picked. So now the hard part is finding the probability for those. So remember, this is a problem in which we're choosing things. We're picking some out of the stack. And then when that's the case, we're going to have our combinations. So to first find out how many ways I could pick 2 DVDs out of the 8 that are there in general, well, to find out the total, That's the combination of 8 choosing 2, because there are 8 DVDs to pick from, and I'm picking 2 of them. So this will tell me how many different combination of ways I can choose 2 DVDs after picking 8 of them. And I think I'm trying to double check what that number is because I don't have the calculator on me. That is 56. So that's 56 there. So there's 56 ways in total to choose 2 DVDs. So now I want to find out how many ways out of those 56 would be discount, would be 1 discount, 1 premium, or 2 premium. So now, remember, for this first outcome, $32, that's only happening if you buy 2 discount DVDs. So if you're choosing 2 discount DVDs, then the number of ways that you can do that would be the combination of, well, let's see here. There are 5 discounts in total. So you're choosing, out of the 5 discounts in total, you're choosing 2 of them. And you're choosing, out of the 3 premium DVDs, you're choosing none of them, right? You're buying 2 DVDs. And this is the case where both of them are discount and none of them are premium. So this is saying out of the 5 discounts that are there, you're choosing 2 of them. And this is out of the 3 premiums that are there, you're choosing none of them. So if you multiply them together, you should have, I believe, 10. Now for 1 discount, 1 premium. So remember there are 5 discounts to choose from. You're choosing 1 of them. And out of the 3 premiums to choose from, you're choosing 1 of them. So that's 15. No. Hold on. Something I did one of my numbers wrong. This first one, 5, choosing 2 discount DVDs, that was 20, not 10. So that was my bad. That's 20 out of 56 there. This one would be 30 out of 56, and then this last one would be 6 out of 56. All right, so those are the probabilities. Anyway, the calculator gets those numbers. Let me go ahead and just put it up here. So if you want to find the expected value, remember the expected value is just where you take that x value and multiply it with its probability. So you take that value, multiply it with its probability, take that last value, multiply it with its probability, and you add them all up. When you add them all up, you get 38. So remember, I think the hard part is really what am I saying? Getting the table set up, knowing all the different ways to spend the money and then the probability of each of those ways, that's hard. But once you have that table filled out, expected values, just multiplying them up together and adding them up. So example 2, a friend invites you to play the following game. 2 coins are selected at random from 6 coins. So again, we're choosing here. So let's go ahead and start by finding my total. There are 6 coins to choose from, and we're going to choose 2 of them. So the total number of ways will be 6 choose 2, combination of 6 choose 2. So typing that in the calculator will tell us the total number of ways we can choose 2 coins out of 6. And I'll get back to that in a second. Now of those 6 coins, there's 2 nickels, 3 dimes, and a quarter. If the sum of the values of the coins is 10, 20, or 30 cents, your friend will pay you 25 cents. Otherwise, you must pay your friend the value of the coins. So this is a very elaborate problem because when we set up our table is going to be set up with the amount of money we win or the amount of money we give our friend. So first, let's figure out the different ways we can choose coins and their totals. So I could pick 2 nickels, which means I pick 10 cents. I could pick a nickel and a dime, which means 15 cents. I could pick 2 dimes, which is 20 cents. I could pick a nickel and a quarter, which would mean 30 cents. or I could pick a dime and a quarter, which would be 35 cents. I believe those are the only ways. If I choose 2 coins, those are the only totals I could come up with for 2 coins. 2 nickels, a nickel, a dime, 2 dimes, a nickel, a quarter, and a dime and a quarter. Those are the only ways I can think of. Yes. Now, remember, that's not our random variables, though. If we pick up 10 cents, that means our friend, some of the values is 10, 20, or 30. Your friend pays you 25 cents. So if we picked up 10 cents, then our friend's going to give us 25 cents. If we picked up 20 cents, our friend's going to give us 25 cents. If we picked 30 cents up, our friend's going to give us 25 cents. So that's said here. If you just pick up coins and the sum is a 10, 20, or 30, then we're going to get 25 cents from our friend, or he's going to pay us some money. It says, otherwise, you must pay your friend the value of the coins. So otherwise is either the 15 or the 35. So if we pick 15, then we have to pay our friend 15 cents. If we pick 35, we have to pay our friend 35 cents. So of course, remember, this happens if I pick a nickel and a dime, and this one happens if I pick a dime and a quarter. So if I pick either of those, then I have to give my friend that amount of money. But otherwise, if I pick 2 nickels, I win 25 cents. If I pick 2 dimes, I win 25 cents. If I pick a quarter and a nickel, I win 25 cents. So these are the different ways we can make money. We're either going to win 25 cents, or we're going to have to lose 15 cents, or we're going to lose 35 cents. So these are different ways. These are my X values, because those are the different ways of amounts of money I could make or lose. Now, probability is a whole different story. So let's talk about the probability of 10 cents. This probability here is only happening if I pick 2 nickels. So this is the combination of choosing 2 nickels. Now, there's 2 nickels to pick from, and I'm going to choose 2 of them. And I'm choosing 0 dimes and 0 quarters. So of the 3 dimes, I'm choosing none of them. And of the 1 quarter, I'm choosing none of them. So that altogether is, I believe, only 1. We didn't get the total yet. So the total 6 choose 2. So the total 6 choose 2 is 15. So all of these are out of 15. So there's a 1 out of 15 way of getting 10 cents. Now I have to come back to that, though. Come back to that in a second. Because that 1 in 15 is combined with something else. All right, so let's talk about the other 25 cents that I win. If I pick 2 dimes, I'm going to win 25 cents. So I'm doing this one here. So if I pick 2 dimes, then of the 2 nickels, I'm picking no nickels. Of the 3 dimes, I'm picking 2 of them. And of the 1 quarter, I'm picking none of them. So this combination here that I've just written down says I'm choosing 0 nickels, 2 dimes, and 0 quarters. Which, if I work all that out, that is 3. So let me write that in red. It's 3. Now, how many ways to choose, a nickel and a quarter, getting this 30 cents? So we're going to do this 30 cents one now. So 30 cents happens if I choose a nickel and a quarter. So of the 2 nickels, I would choose one of them. Of the dimes, the 3 dimes, I'm choosing none of them here in this case. And of the 1 quarter, I'm choosing that quarter. So this is saying of the 2 dimes, you're picking a nickel. Of the 2 nickels, you're picking a nickel. Of the 3 dimes, you're choosing no dimes. And of the 1 quarter, you're choosing quarter. Because remember, 30 cents is 1 nickel and 1 quarter and 0 dimes. So that probability would be 2. That totals up to 2 in our calculator. So now those were all the 25 cents. So if I win 25 cents, it's either 1, 3, or 2. That's 6 out of the 15 ways makes me 25 cents. So 6 out of 15 would make a chance of winning 25 cents. A 1 out of 15 chance for 10 cents, a 3 out of 15 chance for 20, and a 2 out of 15 for 30. But that's together, because all 3 of them are 25 cents. That's 6 out of 15 ways. 1, 2, and 3 makes 6 out of the 15 ways, I win 25 cents. So if I lose 15 cents, it's because I choose a dime and a nickel. So there's 2 nickels, I choose one of them. There's 3 dimes, I choose one of them. And there's a quarter, and I choose not a quarter, so none of them. Oops. So that would be 6, I believe. And then the last one, choosing 35 cents, which means choosing 1 dime and 1 quarter. So 2 nickels, you're choosing no nickels. 3 dimes, you're choosing 1 dime. And 1 quarter, you're choosing 1 quarter. So that is 3. And so if you add up 6, 6, and 3, 6, 6, and 3 does add up to 15. So all 15 ways are counted. So probability is much harder to come about. It takes a lot longer to do. But now you've got your table. So all you have to do to find the expected value is multiply 25 with 6 over 15, multiply negative 15 with 6 over 15, multiply negative 35 with 3 over 15. Add them all up, and you have your expected value. Oops. So there's all that work written down one more time. So multiply them and add, you get negative 3, which basically means that you're going to lose 3 cents on average every time you play this game, since it's in the negative. You're losing 3 cents on average. So it's good to know that even though it's a complicated game, your friend has the upper hand here. Because statistically, he's going to win 3 cents each time you play. You're going to lose the 3 cents each time you play. On average, of course. Example 3, a sales representative makes sales at 20% of the customers he calls. His commissions are $100 each for the first 3 sales, for each of the first 3 sales, and $200 each sale above 3. So in a certain week, he makes 8 calls. Find the expected value of total income or sales represented for that week. So I'm just going to go ahead and put all the stuff on here, and I'll just kind of explain how it all works. There's a little more. Yeah. So he's making 8 calls, and we first need to know, we want to figure out, how many of those calls are successful. So he could make 8 calls and none of them be successful. He could sell nothing, even calling, 8 different customers. He could only make 1 sale after calling 8 customers. He can make 2, 3, 4, 5, 6, 7, or maybe if he's lucky, he could make all 8 sales to all 8 customers. So these are the different ways he could, of course, make a sale. He can make none of them, or he can make all 8 of them. Of course, all the various ways in between. Now, it's Bernoulli because he either succeeds in his sale or he doesn't succeed in his sale. So that's why the formula is there, and I'll walk you through the formula in a second. But back to the sales. If he made 0 sales, then he made $0. If he makes 1 sale, he makes $100. If he makes 2 sales, he makes $100 on each of them, so that's $200. If he makes 3 sales, he makes $100 on each of them, so 3 sales of $100 is $300. Now, after 3 sales, he makes $200. So on the 4th sale, he's making another $200. So if he makes 4 sales, he made $100 on the first sale, $100 on the second sale, $100 on the third sale, and then $200 on the 4th sale, which is why you can see it totals up to $500. So each of these add 200. He makes a 5th sale, he adds 200. He makes a 6th sale, he adds 200, it's now 900. Makes 7 and 8, he adds 200 and 200, gets 1,100 and 1,300 if he makes all those sales. So he could, at the end of the week, he could either have made $0, he could have made any of that amount of money, just depending on how many sales he successfully made. So to find the probability, so these are, if you're making a table, those are the X values in your table, because those are the amounts of money that he can make at the end of this week, depending on how many sales he made. Now, to find the probability, we are using that Bernoulli formula. So that Bernoulli formula was the combination of N, choose R, probability of success to the R power, and then probability of failure to the N minus R power. So we mentioned this earlier in 4.1 video. So remember, N represents the number of trials. So he's making 8 calls here, so you can see that 8 is the N value in all those, because we're all talking about 8 calls. R is the number of successes. So we change that depending on how many sales he makes. So if we want to know 0 sales, then R is 0. If we want to know 6 sales, then R is 6. Okay, so R changes just depending on which of these you're trying to solve for. P is the same every time. There's a 20% chance he succeeds when he sells. So that's why you can see the probability is 0.2. That's our P value in all these. Q is the probability of failure. So if he succeeds 20% of the time, then he fails 80% of the time. So the probability of failure is 0.8. So again, that's consistent in all of those. Of course, the R and n minus R are the exponents. So if R was 0 here, then R is 0 here, and n minus R is 8 minus 0, so 8 minus 0 would be 8 there. So that just fills all these in, right? If R is 3 for 3 calls, then R is 3 here, which means 8 minus 3 is 5. So that's the exponent for that. So again, all of these are just variations of this formula, but obviously they're different depending on whether you make 0 sales, 1, 2, 3, 4, however many sales you make. And you let the calculator do the math, and then these are your probabilities. So if you made a table, these are your x values in that table, and those are the probabilities in that table. So if you want to find the expected value, you multiply them together. So 0 times that probability, which you can see I'm just saying times 0 on this side, so I don't have to draw this line all the way across. These are, again, just the x values repeated. So they're over here for the sake of convenience. But you multiply these x values with the probability, and you get these numbers. So multiplying them together, multiply those together, multiply those together, multiply those together, and so on. You get those numbers. If you add up all these numbers, you get your expected value. So when you add them all up, it's a 166.80. So that means on average, this guy would expect to earn $166 per week. Obviously, that's an average. He can't go home with $166.80 because he's either going to go home with one of these values. But if he did this week after week after week, some weeks he would go home with $100. Some weeks he'd go home with $200. Some weeks he'd go home with $300. Who knows? But the average of those weeks would be $166.80. That would be his expected average. All right, so for a binomial random variable, which is specified, the expected value is just n times p. So these are very, very simple problems. It's like a complete 180 from what we were just doing. So remember, n is the number of trials and p is the probability of success. So let's say a political poll is to be taken by mailing 1,000 questionnaires. So 1,000 is our trial number. We're sending out 1,000 questionnaires. So 1,000 is our n value. It is known that the probability of any given questionnaire will be returned is 0.14. So 0.14 is our p-value. It's our expected return rate, right? 14%. Probability of getting these back is 0.14, 14%. So what's the expected number of questionnaires we expect to get? So if we send out 1,000 of them, and we're expecting 14% to come back, well, 14% of 1,000 is just 1,000 times that 0.14, which is 140. So we're expecting 140 questionnaires to be returned. And that's it. That's all that is to that problem. So an NBA basketball player makes 30% of his three-point shot attempts and 45% of his two-point shot attempts. If each year he attempts 300 three-point shots and 800 two-point shots, what is the average number of points he makes per year on field goals? So it's basically the same thing as the last problem, but in a couple stages. So his three-point shots, he is attempting 300 three-point shots, and he's expected to make 30% of them, so 0.3. So if he takes 300 and he makes 30% of them, that is 90 made shots. So he shoots 300 threes, but makes 90 of them because, he makes 30% of them. For his two-point shots, he is attempting 800 two-point shots, but he's going to make 45% of them. So 0.45. So 45% of 800, 800 times 0.45 is, I don't know, hold on. What is, hold on, I gotta get a calculator. Give me a second. 800 times 0.45, 360. So 360 shots made out of the 800 that he took. Now, again, these are not the points, so these are just the number of shots that he made. So these 93 pointers, that's 93 pointers. So multiply this by 3 to tell you how many points he actually scored there. So I believe that's 270. If he made 360 two-point shots, then multiply that by 2 for 2 points, 360 two-pointers. That's 720 points from those. So 270 points from 3-pointers, 720 points from 2-pointers. If you add them up, that's the total number of points that he makes, which is 990. All right, and this is the part where I think we're gonna end this standard deviation kind of at a different time. All right, so I'll see you guys in section 4.3.